Hello. In this video, we'll talk about generating constants. So far we've looked at operands stored in registers and operands stored in memory. Now let's look at constant operands, also known as immediates, because they're immediately available as part of the instruction. So some instructions like add I can take a 12-bit immediate as part of the instruction. Let's say we had this program, A gets minus 372 and B equals A plus 6. And we wanted to keep A in S0 and B in S1. Then we could use the add-immediate command. Add-immediate S0 gets 0 plus negative 372. That will add 0 plus minus 372 and put the answer of minus 372 into A. Then we could do another add-immediate. S1 gets S0 plus 6. That does the B equals A plus 6. Because our instructions are of finite length, we can only store immediates of finite length. And as we'll see later, in the RISC-V instruction set, we can only store immediates up to 12 bits long. However, those immediates are stored in 2's complement form, and they're sign extended to 32 bits. So we can store both positive and negative numbers in the range of minus 2048 up to positive 2047. Suppose we needed a longer constant, something up to 32 bits. RISC-V has a special instruction for that situation. It's called LoadUpperImmediate. LoadUpperImmediate puts a 20-bit immediate into the upper 20 bits and zeros into the bottom 12 bits. And we could follow that by an add I to add the values to the lower bits. So let's say we wanted int A equals this 32-bit constant FEDC 8765 in hexadecimal. And suppose A was in S0, we could do a LoadUpperImmediate. S0 gets FEDC 8. That's the upper 20 bits. And then we could do an add I. S0 gets S0 plus 765. That adds the 765 to the lower 12 bits, completing our 32-bit number. LoadUpperImmediate only needs a single register and then an argument, an immediate, and that's why there's space in the instruction for a 20-bit immediate. So even though we're saying simplicity favors regularity, this is a case where we're making good compromises to be able to handle 32-bit instruction with a special, or 32-bit immediate with this special LUI instruction. It's important to remember that add-immediate is going to sign extend the 12-bit immediate. So if the 12-bit immediate had a 1 in the most significant bit, that is going to get sign extended and create 1s in all the other bits. And that effectively makes it look negative. So if we want to do load a constant that's 32 bits, where the most significant bit of the bottom 12, it's bit 11, is a 1, we need to increment the upper bits of the LUI by 1. So let's say we wanted to get FEDC 8EAB. We could do an LUI of FEDC 9 instead of 8. And then EAB is negative 341. So we could add negative 341, which is FFFFFFEAB. Add it to the FEDC 9000, and we get our desired FEDC 8 EAB. So if you are trying to create a long constant like that, you got to be careful of this bit and handle it.